When was the last time you had to do this? Or this to get across a stream, river, fjord, or lava pit? Probably never, because we have these things called bridges. Bridges are awesome. But what are all these different types of bridges that you see around? Why don't they all look the same? Let's find out. Engineering. The most basic type of bridge is a beam bridge. It has the most simple design, with the beam, also called the bridge deck, that is supported at both ends. Let's drop into our diagram mode to see how the forces act upon this bridge. When a load is applied to these bridges, they bend and experience two types of forces. The top of the beam is pushed together, which is called compression. The bottom of the bridge is pulled apart, which is called tension. Here we are using lasers to build model bridges out of balsa wood and plywood. Always wear purple gloves while handling balsa wood. Safety first, kids. You can see the simple design. Now let's see what happens when we apply forces to it. To do this, we'll use a compression tester that can apply up to 20,000 pounds of force, although we probably won't get that high in this test. The compression tester will apply a load, or in other words, a weight, and measure the strain, which is how far the material moves in response to a load. Also to help us on this test will be these Lego people, who will measure the ability to be launched from a bridge when it breaks. Critical information for bridge designers. Officer.
Hello.
You see that as the load increases, the bridge bends, and eventually breaks at a load of 115 pounds. But now, what if you want to span a longer distance? Here we use the same deck material on top, but we have doubled the length of the bridge. This time, our main test subjects will be the happy farmer chef, hat man, bike guy with no helmet, shame on you. You can see that the longer bridge bends even more, and it breaks at a much lower load, only 25 pounds, which is 80% weaker than the short beam bridge. Plus, the Lego people get launched into space. That isn't very good. We want the bridge to support a lot of weight over a long distance. So how can we make bridges that span longer distances? There are other bridge designs that allow us to use the same deck material and span longer distances. This takes us to the curviest of bridges, arch bridges. An arch is a great way to evenly distribute a load and has been used in bridge building for a long time. In this example, we just have a beam bridge with an arch underneath. The load is distributed through the arch into the ground. Notice how only compressive forces are present and no tension forces. This is great for wood and stone bridges because they are much stronger in compression than tension. In our model arch bridge, we use the same long bridge length with added arch supports on both sides. To help us is Tricycle Man, helmet, good job, classy businesswoman, and this crazy guy. Let's go. You can see that the beam does not bend as much with the arch underneath, and that reaches a higher load before it fails, 100 pounds, which is 500% stronger than the long beam bridge. Here we have seen that beam bridges get weaker as they get longer. Adding an arch makes the bridge very strong, but arches have length limitations. Beam and arch bridges historically have relied on wood and stone as building materials. These materials are usually only strong in compression and not in tension, which restricted the designs that could be used. However, with the discovery of steel, bridge builders now had the ability to add structural units that would be strong in tension. This led to more intricate styles of bridges that we will explore in our next video.